right, welcome back to section 4.2. This is hopefully the last video of the 4 that I intend to make. This one might be a little lengthy because there are quite a few examples in this one. So we're going to go all the way down to the section that deals with compound interest. Oops, I went too far. There we go. On page 4-7. All right, so compound interest, first of all, let me just walk through with you what each of the letters means in our formula. And you'll notice here the formula is written right down here. And so we have P dollars. This is going to be the initial amount or the starting amount. This is the amount that we're depositing in an account. And we're going to be paying an annual rate of interest. Our interest rate is going to be R. You always want to write your rate as a decimal. This interest rate is going to be compounded a certain number of times per year, and that is going to be called our N. Now, so take a break for just a moment. Our N, the words that we're going to use for that, you could say it's going to be compounded annually or compounded semi-annually. Or maybe it's going to be compounded quarterly or monthly or daily. Those 5 words are going to change what my N value is. So if I'm compounding annually, my N is 1 because it's 1 time per year. If I'm compounding monthly, my N is going to be 12 because it's going to be 12 times per year. So you just have to pay attention to what that word is. T is going to be time, and it's always going to be measured in years. And then the account, the final amount is what A is. And so this is what the account is going to hopefully grow to while it's just sitting in this account, while my money is sitting in the account. One small note is that I noticed for this particular textbook, the power that they use here is T times N, and you'll notice that I've used an N times T. Please note that that is the same thing. It's just simply that every book I've ever taught out of uses N times T, and so I just didn't change it around, creature of habit. All right, so let's look at example 7. You'll notice that the first thing I did was I wrote my formula, and I am investing $2,500, so that's going to be my P. My account has a 3% interest rate, so remember we're going to write that as a decimal, so this is going to be 0.03. Remember that you change a percent to a decimal by moving to the left 2 places. I'm compounding semi-annually, so this is 2 times per year, so my N value then is going to be 2. Part A says, find the amount that's going to be in the account after 10 years without withdrawing anything. So let's go and plug everything in the way we want it. So we have 2,500 times the quantity, 1 plus 0.03 divided by 2, all raised to the 2 times 10 or the 10 times 2 power, depending on which formula you chose to use there. And this is something that you're just going to enter right into your calculator. So you enter this into the calculator, and you're going to end up with $3,367.14. I always get the question, how do you know how to round? And remember that this is money, and in America, we round money to the nearest hundredths place, so the dollars and cents. So we understand that. We always forget it, so. Part B says how much interest is going to be earned over that 10-year period. So this is the deal. You deposited $2,500 and then you left it sit for 10 years and you ended up with $3,367.14. So how much did you earn then over that 10 years? So what you want to do is you want to subtract those two, and you can see that you earn $867.14. All right, let's look at example number 8. So example number 8 says that you have Brendan who has to pay a lump sum of $15,000 in 8 years' time. So part A says, what should he deposit today at 2.4% interest rate? So we know that we're going to write this as 0.024. He's compounding annually, so my N value is going to equal 1. And so what does he have to deposit today that's going to give him $15,000 in 8 years? So once again, you see that I've written my equation. Let's go fill in what we know. We want $15,000 in the future. So that's going to go in for my A value. And then our P value, we don't know because this is what we want to deposit today. And so my quantity then is 1 plus 0.024 over 1. Remember, it was annually, so that's 1 time per year, raised to the n times t power. So 1 times my number of years, 1 times 8 power. All right, so the first thing that you ask yourself is, what kind of math is being done to the p? Well, p is being multiplied, and the only way that we can get rid of multiplying is by dividing. So we're going to divide on both sides by that quantity, 1 plus 0.024 raised to the 8th power. You'll notice that I cleaned it up a little bit. We know that this division just gives me 0.24 or 0.024, and my power, 1 times 8, is just 8. So then this is what I'm going to go type into my calculator, and I'm going to get $12,407.71. So we say then, he has to deposit $12,407.71 today to be able to have $15,000 in 8 years. Well, what if there's a problem? What if he's only saved $12,025 to be able to deposit today? What interest rate does he need to have to be able to still have that $15,000 in 8 years? So once again, you see that I have written the equation. It's covered up a little bit, but I've written the equation down. Let's go and fill in the necessary information. We want $15,000 in the future. $12,025 is what I can deposit today, or what Brendan can deposit today. And we have 1 plus, we don't know R, that's what we're being asked for, what annual interest rate. So we don't know R. We're still compounding annually though, so our N value is still the same. It's still a 1. And we're still going to raise 1 times 8 for our power there. So let's do a little bit of cleanup. The first thing that you need to understand is that I want to isolate this base somehow. And the way to do that is to isolate the base and the power. So the first thing I want to do is let's get rid of the $12,025 and let's divide on both sides by that. So I believe that that's probably what I did first here, yeah. And you'll notice too on the other side that I did clean up my quantity. R over 1 is the same thing as R. 1 times 8 is the same thing as 8. All right, well, how do I get rid of an 8th power? Well, we would do that by taking the 8th root of both sides. Or another way of saying that is I can raise both sides to the 1/8 power. One thing that I want to remind you of is that any even roots, whenever I take an even root on both sides, I need to remember the plus or minus. But folks, the thing is here, this is dealing with money. And in this particular case, we're not going into debt. So we don't have a negative amount of money here. We are only going to keep the positive value of our money. So just keep that in mind here. All right, so we have both sides then raised to the 1/8 power. We like that because now our 8 and our 1/8, they're going to cancel each other out. When you raise a power to a power, you multiply your powers. So this is just going to leave a 1 plus R on the other side. Well, now all I need to do is subtract 1 on both sides. And this is what I'm going to enter into my calculator. When I enter this into my calculator, I'm going to get this decimal. And I'm going to keep quite a few decimals here, 0.028018. So see if you get the same thing by typing that in. But remember, we were asked for what interest rate? Well, we write our interest rates in percentages. So let's change this decimal back into a percentage. And so my rate then will be 2.8%. If he can have a 2.8% annual interest rate, then he'll still be able to get that $15,000 in 8 years. All right, so the next thing that I want to look at is this number called E. And what we're looking at is they give us a hypothetical question. It says, suppose a dollar is invested at 100% interest per year. Let's compound it n times per year. And the interest rate, because we're writing it as a decimal, when you write 100% as a decimal, that's 1. So the interest rate per period then is going to be 1 over n. So we're just simply here using our little formula that we already had. And according to the formula, since our initial amount is 1, then the compound amount, what I'm going to earn by the end, is going to be this value right here. All right, so what we're being asked to do is we're asked to take the number of times we compound per year and start raising that. Like right now, we're only used to doing that annually or semi-annually or monthly or daily or quarterly. This is saying, hey, yeah, go ahead, compound it 1 time in the year, that's annually, or compound it twice in the year, that's going to be semi-annually. This one we're not familiar with, we don't have a word for it, but compound it 5 times a year until we get to the point where it says, no, compound it 1,000,000 times per year. So let's look at what would happen then if I keep increasing the number of times that I compound my interest. So if I compound it semi-annually, we're going to get 2.25 or $2.25. And if I compound it 5 times a year, I'm going to start keeping a lot of decimals. You'll see why in a moment. So I'm not just keeping the number of decimals for money here. If I compound it 5 times per year, I'm going to get this decimal 2.48832. Well, then let's compound it 10 times per year. And you'll notice that each time my money amount is going up a bit. Well, then if I unhide all the rest, you can pause the video and go ahead and take your calculator out and figure out the next 4. I'm just going to unhide them all at the same time. And what you're going to notice is that each one, yes, it keeps raising, but the more times I compound per year, the less it raises. In fact, it looks like it's starting to get close to this magical number of 2.718 something. And what we end up finding out is that as n keeps getting compounded more and more and more times per year, my function is getting closer to a fixed number. My fixed number has a name. It's called E. In fact, if you'll look at your calculator, I don't think I have, oh, good, here's my calculator. If you'll look at your calculator on the left column, and you don't need to worry about what's there in my screen, but on the left column, notice that there's an LN button. Right up above the LN button is this little symbol that says E raised to the X power. So let's do this. Let's look at E raised to the first power. This is going to give us the value of E. And you'll see there's our magical number, 2.718. 2818285, and it's going to keep on going forever and ever and ever. It's a lot like pi in that it has an infinite number of decimal places. So let's go back to our notes then, and you see that the value of E is this number that I can find in my calculator. E, please note, E is a number. It is not a variable. It is not a letter that can change as much as I want it to change. Well, one way that I can use E is for continuously compounding. So this is for compounding more often than annually or semi-annually or quarterly, monthly, or daily. This is for compounding every moment of every day. And what you see here is I still have P dollars. This is still my initial amount. I still have my interest rate that we're still going to write as a decimal. I still have my time measured in years. And I still have my future amount that is called A. The only thing that's different here is that I have this number, this 2.718 yada, yada, yada number that's in my formula. For the record, I do call this the shampoo formula. For those of you who are listening and you are over the age of 40, you'll know what Pert shampoo is. For the rest of you, go look it up. They still sell it. But I call this one the shampoo formula, or sometimes I'll call it the clean formula. I'll go back to this one. Sorry, it's all the way back here. And this one I call the dirty formula simply because it's messier. It has more stuff in it. So the clean formula and the dirty formula. And so look at example 9. We're depositing $8,000. Our account is going to be paying 5% interest, and we're going to compound continuously. So we're good. This is what tells us to use our shampoo formula or our clean formula. And we're going to do this for 6 years. So we want to find the future amount or the total amount that we have at the end of 6 years. So I've written down my formula. Let's go and substitute the values that we need to. So 8,000 is our starting amount. E is our number. And so we're going to use our calculator here in just a moment. R is 0.05. Don't forget to write it as a decimal. And then times our time. So use your calculator then, and you're going to use that E button. You're going to raise that E button to the 0.05 times 6 power. I'll do this first one for you. I'm not going to always show you this, but so we have $8,000. Whoops, let's get rid of that. $8,000. And we're going to multiply that by E raised to the 0.05 times 6 power. And then you can see there that we have the value of $10,000, $10,798.87. And so if I uncover what I have here, that's exactly what I've got, $10,798.87. Now, back in example 7, so I'd like for you to pause the video and let's go back really quickly and look at example number 7. We found that the total amount of deposit after 10 years in our account, we paid 3%. Semi-annually was $2,500 that we were investing. We're asked to not just look at this semi-annual investment, the semi-annual compounding. We're asked to look at the other types of compounding as well. So let's go compare. What does it look like if we compound it annually, or quarterly, or monthly, or daily, or even continuously? So the first 5 of these, we're going to use that messy formula, the dirty formula. Now, you can just go back to example 7 and copy the semi-annually. We've already done that work, so let's not take any extra time to do that. So that's going to be $3,367.14. That's what we found back then. Notice that I didn't even write down a value for annually, and I'm being lazy here. It didn't ask me for annually. It only asked me for quarterly, monthly, daily, and continuously. But you can find that if you want. I did not even write it down in my paper notes to be able to hand that to you. All right, if we invest quarterly, that's going to be $3,370.87. Monthly will be $3,373.38. Oh, we gained a whopping $2 and something. If we compound daily, this is going to be $3,374.61. And then if we compound continuously, so this is the one where we need to change our formula. So we compound continuously, we're going to get $3,374.65. So you'll notice that each time I get a little bit more. It's not crazy significant, but it is a little bit more. All right, for the last example of this section then, let's look at a non-money question. So we are told that the exponential growth of the deer population in the country can be calculated by using the following model. And so here's the model that they gave us. And now they're going to explain what each piece is of the model. So 20,000 is the initial deer population. 0.08 is the rate of growth. T is going to be the total population. And N is going to be the number of years that have passed. So for part A, we're asked to predict the total population after 4 years. So we're going to keep our equation exactly the same. The only thing that we're going to change is our power. And so 4 years have passed. So we go and we plug that into the calculator. and we get 27,209. But please note, we were supposed to round to the nearest thousand. So we're not going to, and by the way, you cannot have part of a deer. So, if your calculator said that you had 27,209 and 0.78, it's kind of going to get messy if you have 78 hundredths of a deer. So be careful about that. You cannot have a part of a deer without it getting messy. But this was asking us to round to the nearest thousand. So this is going to be 27,000 deer approximately in 4 years. Now, part B asks us a different question. It says, if the initial population is different, let's say it's 10,000, and now the growth rate is 15% or 0.15, approximately how many deer are going to be present after 2 years? So again, we'll use the same formula, except that we're going to just change some of the numbers in our formula. So the initial amount is going to be that 10,000. My rate of growth is going to be 15%. And the number of years now is going to be 2 years. So we'll throw that into the calculator. And once again, we were asked to round to the nearest thousand. So the answer that we would enter into our system is going to be 13,000 deer approximately. All right, that takes care then of all of the videos that we have for section 4.2.